Hey folks, so I'm Satyarth. I work in the Gojek mobile developer experience team, and with a focus primarily on Android. And I work on like a bunch of Android systems, worked with Android frameworks, libraries, CI/CD, and right now just on mobile SRE as subject. So welcome. Today we'll be talking about agility in the mobile world. Just a brief introduction of our speakers. So I'm Satya. Like I mentioned, I work on like general purpose Android stuff at Gojek. Rajesh is a principal Android engineer in the driver platform team, and Rahul is also a principal Android engineer in the driver platform team with a focus on performance. Right. A brief agenda for the day. So we'll start with the Gojek journey, like how Gojek's been growing from 2015 to now. We'll talk a bit about releases at Gojek, which is how do we do mobile releases. We'll also over like user adoption and then finally on application vitals. So the first up is like essentially Gojek journey, right? This is something which I'm not sure if you went earlier, but like, so Gojek is an on-demand platform for Southeast Asia. We do huge number of orders per day. We have multiple services, and we are pretty much like a super app which caters to all the needs of people in I think we are right now in 4 Southeast Asian countries right now. So yeah, Gojek started in 2016 as an on-demand service. We started with about 4 services, which is basically courier, which is transporting parcels from point A to point B, transport, moving people from point A to point B, food delivery, and shopping. Fast forward to 2018, and we had expanded into multiple different types of services. It was possible to now take a bike from A to B, a car, order food, get shopping done, send parcels from A to B, and even send cargo from A to B. And now fast forward to 2022, right? So we have a huge number of services which are a part of Gojek, and it did not seem feasible to be actually listing them on the home screen. So we moved it to a cute little more button where you click on that and you can see everything that Gojek provides. So today, we're going to focus on this particular screen itself, right? The protagonist of this story is the Gojek home screen. This is a representation of us. We have Gojek in 2016, 2018, and 2022. Right? This is some screens which you must have seen as a part of the Gojek presentations and so on. This is something which almost every Gojek user must have seen again in their lifetime. The home screen itself has undergone a lot of iterations. Right now, while we display 9 of them, there have been 100 plus, which our users have established and have seen. We realized that we learned quite a lot on the way. And I'm here to discuss on like essentially how we learned or what we learned over here. The home screen journey has been quite long. People talk about like how they work on a particular app for 3 years, 4 years. I can probably say I've worked on this particular screen itself for like 3 years because there's just so much which happens here. We have done a lot of iterations with this particular screen. Since 2019, we have done more than 10,000 isolated experiments on the screen itself, and this includes only one platform. We have also, if I were to include multiple platforms, this would be about 15,000 plus. We have had about 6 major redesigns on this page, thinking about like rethinking every entry and exit. And for us, like my team, when we are working on this, the home screen was essentially like this collection of Lego blocks, right? So while working on it, we would build different variants of it just for fun to see how we can compare notes and then see how the experience runs on them. So the home screen has pretty much been like this iterative loop where we realized that it was not possible to build the perfect product in the first go. And the best way to learn was to actually get feedback from the users and understand what worked, right? So what did we end up learning as a part of this process? A few of them were quite important. So the first one was you really do not interfere with core user paths. So power users they use multiple services and they get very touchy when you actually change something which works for them, right? We are used to using phones. And so if we have problems when we use software and someone changes it, you can imagine how it would be for the end users too. This was really good for us because we had users who cared about the product, who were passionate about it, and then gave us feedback on it. We also realized that building a habit takes time, and it makes more sense to nurture the habit instead of trying to modify it, right? My favorite lesson, like out of this all lot, was that you think that after doing so many experiments and understanding or trying to figure out what users like, we know the exact home screen that a Gojek user wants, right? Uh, well, that was not really the case. In sense, we realized that there is no one size fits all for this situation. We understood that it was important to personalize and contextualize the home screen for our users. And we focused on making sure that every Gojek user who sees the home screen, it's a personal experience for them and what they need at that particular moment. All right. So based on this, we identified that there are releases. Like essentially, we need to get iterations done, and to be able to iterate, we need to be able to analyze. And hence, we have to go on releases, and prior to that, we do development. So the cycle essentially is develop, release, and then we move towards analyzing what we've built, right? So as the business use case is required, we need to iterate fast to be able to understand what our users need. This requires us to analyze fast because we need to be able to understand like what feedback we get and what works next. And consequently, this trickles down to having to requiring us to release fast. Prior to that, like if we want to release fast, we need to develop fast and hence also verify fast. I think we can all see like where this problem goes as the size of this software increases and as the number of features we have increases. It's really not possible to stay at the same speed or even increase speed over here. This became a bottleneck for us where we were not able to develop features and release features fast enough for what our requirements were and like in growing and the changing market that we were in. So over here, I'm going to take a detour. I'm, I would highly recommend this book. The book is called The Phoenix Project, and it was pretty much like a mandatory reading for anyone who joined the mobile developer experience team. So I want to talk about one concept which is brought up in this book, right? There was a, like the protagonist in this book is also responsible for the DevOps and the release in their organization. So they do this particular segment where they know that their stakeholders are not happy with them and they go and actually talk to them to understand what their stakeholders expected from them. So we saw that while we were doing releases, the releases would get delayed by a day or two, and there would always be a push for we need to push a feature in this particular release. So we decided to go and talk to the product owners to understand why this was happening. And that conversation was very insightful and pretty much helped shape our release process, right? So we asked them why they want to push features for this particular release if it is not completely ready. The reply we got was that because we don't know when the next release will be. And we were surprised by that because we have a calendar which signifies, like we have code freeze every 2 weeks, and we showed that to them saying that, okay, code freeze happens every 2 weeks, so you know when it is. They then told us that yes, even though code freezes every 2 weeks, that does not really guarantee that a release will happen every 2 weeks. Because once you have code freeze, you have the verification cycle which kicks in, which can take anywhere from like 2 days to 5 days, depending on how many features, how much, etc., and the level of automation you have. And after that, we have the release, like just publishing the application itself to the Play Store and the App Store, which then follows a review process and then needs to go undergo adoption. This can easily take between 1.5 to 2 weeks. So effectively, if they were not able to participate in this release, they would be have to wait like for the next release and 2 weeks post that, which is almost a month. And a month's delay is something which was completely unthought about. Like you cannot consider waiting for a month to push a feature which is almost ready in such a fast-paced world. This made us understand like what problem we needed to solve. So we decided to tackle releases itself, right? We made a plan. Like the plan was essentially that we'd be as consistent as possible with releases. So we first decided that a release occurs every second Wednesday. This was fixed. We would make sure that this is the date the release happens and not focus on code freeze itself, right? Then it was important for us to be consistent. Like come rain, come shine, we will do a release every second Wednesday, and there was no deviation in this plan. We had cases where there were company-wide hiatus or certain requirements which required us to change or push a release date, but these were communicated well in advance, about a month or 2 months in advance, so people could be prepared for that. And it was a regular affair. So what this means is that we stopped treating releases as a special event. Uh, it was pretty much like how the sun rises every day. We have releases which happens every 2 weeks. There's no difference between 2.1, 2.2, 2.3, and so on. And this was like an organization-wide cultural shift where we needed people to stop thinking of releases as major milestones and instead a metro train which they would be a part of, right? All right, so did it help making all these changes? It did help. Like if you'll see the graph on the right side is a graph of the days between major releases and like over the years, right? So around 2019 mid was when we realized that this is a problem and we started working on this. We had a few hiccups initially where we could not really figure out, like just basically convincing everyone, making sure that this is the guideline they could stick to and so on. But as you'll see, as time proceeds, our deviation in like the variance in the number of days we have between releases reduced. And we reached a point where we were quite stable at about 2 weeks of the duration between releases. This also had a great side effect in terms of the number of hot fixes that we started shipping with releases reduced. In the initial releases, we'd have a hot fix with almost every second release. But as time progressed, because of this consistency and people knowing that the next release would be 2 weeks away, and also because of the experimentation rollout, etc., which I spoke about earlier, we were able to significantly reduce the number of hot fixes that we pushed, which meant a better experience for our end users, more consistency and predictability for our product team. And this also trickled down to like happier developers and verification teams. All right. So in summary, I want to say that it was important for us to prioritize communication and visibility because we had to inform and make sure that the entire organization was on the same page of when releases occur. This is a calendar which is shared almost like a year in advance, to the point where now we don't need to really share a calendar because it is very well known fact that this happens every 2 weeks. In terms of visibility, it was something about making sure that information like, for example, how user adoption is on every release is easily accessible. So it became possible for product owners to plan and roadmap thinking 4 to 5 releases in advance because they can project when they can get the required user adoption, right? We chose we chose consistency and reliability over speed. So agility focuses on doing things like one focus of agility is to do things as fast as possible, right? But it was also important for us to be consistent and make sure that releases happen at a regular schedule and also being reliable in that we could meet that schedule and we did not deviate from it much. Lastly, we realized the importance of correct metrics. So we initially started focusing on like code freeze dates need to be fixed. And we later realized that this was not really how it works towards our users because as developers for us, a release is the final stage, but that is pretty much the start for a product, right? So once a release happens is when the users get adopted to that particular release and features are verified, hypotheses are tested, and then we get feedback to do the loop again. So it did not make sense for us to focus on code freeze and instead look on user adoption and perhaps release as metrics for this. So at this point, we identify that the cycle is essentially we need to be consistent and regular in a develop, release, and analyze cycle. So this was good. This worked fine and dandy for us up to a certain point. And where we hit another roadblock, right? At this point, we realized that even though we are making releases regularly, we were not able to get the adoption that we significantly wanted. And hence, it did help or it hindered our analysis. We were not able to iterate that fast because there was still this unknown factor of adoption, which in the mobile world is a pretty big thing. It's not something as simple as like when you push a website, everyone ends up using it, but we needed users to download the app to be able to use it and want to do that. So next up, we're going to focus a lot on how we dealt with the adoption problem at Gojek, which Rajesh will be talking about. Rajesh, over to you.
Hello everyone, I'm Rajesh Khetan, currently working as a principal Android engineer in Gojek. I focus on making sure that that the drivers we have, right, make enough earn enough money from our Gojek platform so that they can have a sustainable living, and also improving drivers' experiences on while using the Gojek app, right? So today I'll be discussing about app adoption. Let's say we have built a very good app which is quite successful and a lot of users is using that app, right? And we keep on adding new features and we do a lot of experimentation on those features, as well as like we roll out the best designs. But how do we make sure that uh, the app is getting adopted by a lot of users, right? The users are actually updating to the latest version of the app. So we at Gojek identified some of the problems with app adoption and we worked on them. And today, like we'll be discussing about those problems and how we tackle them in Gojek, right? So to start with, let's look into the smartphone market, how it is structured, and then we'll proceed accordingly. So we have OEMs who manufacture Android smartphones. Uh, and so which ranges between from low range to premium range. Low range devices are cheaper devices which have low memory and low storage, and premium devices are high end devices which have abundant uh, memory and storage, right? So let's say, and also there are certain users which are targeted for each range of devices. So like users with less budget would go and buy low range devices. So now let's say we have built an application which we target to all different range of devices, and it looks good. Like every user is able to use our app. And then as our application becomes successful, we start adding new features, and with new features we add new libraries, and hence our applications becomes large, right? So this brings a problem where now we might have a risk of not being able to cater to the low range devices, because low range devices have uh, low storage and they might have to prioritize between different apps which they want to keep on their smartphone, right? Because they don't have enough space to have all the applications. So this brings a risk for us that they might go and uninstall our app, or maybe like not update to the latest version of our app, and then we might lose this particular segment of users. So so this is a problem which we face with adoption, and we let's and we'll like we also try to solve it, right? So let's look into different problems which uh, are there when our application becomes larger we face, right? So one is before understanding the problems, we need to see how our app launching how our app is actually launched, right? So we have a launcher application like the home screen which you have in your phone, and then we have a lot of application icons on that screen, and whenever you want to open an application, you generally click on that application icon, and then your application is loaded into the memory, right? And then is when your app is launched and you will be able to see your app. So the third phase here, right, which is when the application is loaded into memory, is quite important, and it is uh, the time which is required to load that app into memory is directly proportional to your size of the app, right? So the more the size is, the more it will take time to load the app, and hence it will also require more memory to run the app. So if the size is more, it will take up more memory. Uh, and the third point which we have here is like the internet cost, right, required to download the app is also proportional to your APK size. So this might not be a problem in a lot of countries, but this is actually a problem in some of the emerging markets where internet costs are high, and a user needs to think twice before they want to download any large app, right, or update the app. So these are some problems which we can see with growing application size, and we also try to solve them. So there are majorly two problems which we'll be discussing here today. One is like how we make our application size smaller, and the second one is like how do we make sure that our application becomes faster, or the load time of our application is fast, right? So that the user have a smooth experience while using our app. So also look at what how the Gojek story looks like, why we landed up into these problems, right? So in the past few years, Gojek has been growing very fast. We started adding a lot of new features to make it easier for our customers to use the app. And like the whole company was basically focusing on adding new features and providing as many features to the user Yep, and then we saw that like because of this, the app size was also growing very fast, which no one was looking into, right? Because everyone was focused into building new features. And then because of new features, we added a lot of those features required initialization during app startup itself. So which slowed down our app startup as well, right? App startup time was increasing because of two reasons. One was the app size was growing, as well as like the new features which were being added required initialization during app startup. And so these were kind of how we landed up into these problems, because our focus was mostly on adding new features to our app, right? Uh, and let's look into some stats, which is like if you see at a point in time, our APK size for the Go Partner app was around 80 MB, and for the Gojek app, it was like reaching 90 MB, which was like all-time high for us, and it was never stopping. It was just increasing and increasing. And also, if you look at the cold start sessions, we had around 24 percentage of sessions which were like taking more than 5 seconds for the app to start, right? So this might not again be a problem for premium devices, but these were actually problem for low end devices. So let's also look at how our user base looks like, right? So we had 21% of our users with less than 2 GB of RAM, and around 6% of our users with less than 1.5 GB of RAM. So it was very important for us to provide the best experience to this particular range of users, and this became like a primary focus for us, and we started working on them. So let's start with the first problem, which is APK size and how we reduced it in Gojek. So uh, there are two things which I'll be discussing. One is like how what is causing the APK size to increase, what are the different parts which we change and which leads to APK size increase, and the second one is like how we at Gojek took both reactive and proactive approaches to solve them, right? So reduce the APK size. So let's start with what contributes to the APK size. So if you look into a uh, application, so also one thing which I would like to mention is like the things which I'll be discussing here are not only applicable to Android, but are also applicable to like all the principles are also applicable to iOS, and we at Gojek also apply those principles to our iOS apps. Yeah. So uh, so if you look into an Android APK file, right, you will see these two files, which is the metadata file and the manifest file. So the metadata file is basically the data about your APK, and manifest is like the blueprint of our Android app. So these two files are mandatory files which will be present in all APKs, and they don't even take a lot of size. So these are something which is like always present. And then we have assets and resources. Assets are raw files which we add to our APK. Uh, those could be like MP3 files or some sound related files or any other files, right, which we add as an asset. And then resources are basically our drawables or images which we add to our APK, right? So this resources doesn't actually include the values folder inside our app. The values folder is part of our resource table, right? So the resource table basically holds two things. One is all the IDs for all the resources. So in Android, like we have a R file, right, where we for each resource an ID is generated, which is stored in the R file, and which stores the mapping for each resource. Like the ID is mapped to the actual resource. So the resource table actually stores the mapping of all these resources which are present in our resource folder, as well as it stores all the resources which are actually stored in our values folder. So like the strings, colors, or styles, and everything like that, right? And then we have dex files. So because like a dex file has a limit of 64k methods, if your application has more than 64k methods, it will be divided into like multiple dex files. And these are basically the Java and Kotlin code which we add to our application. And then we have native libraries. So this is the C++ code. So we which is like targeted for a specific architecture. So we have multiple native libs if you want to target multiple architectures, right? So these are the things which are present inside an APK, and then we'll Next, we'll look into the reactive approaches which we use to reduce our size. So we'll be focusing on this particular set of things which are in the APK resources, and then our resource table, our classes and native libraries, right? Let's start with resources, like what we actually did at project to make sure that our resources size goes down. So the first thing which we did is like using resources from design library, right? So we at Gojek at a point of time realized that we have multiple apps and we need the design of these apps to be consistent. Like all the cards or any images which we are showing should be consistent among all these apps. So we started building a design library so that we can provide a consistent experience to all our users. So uh, so before the design library came in, we had something like this. We had a feature X which we are shipping, and we had some images which we are using in this particular feature, right? So as the design library came into picture, we introduced this library as well into our application. And this design library had the same set of images which we had in the older feature. So now if you see, there are like multiple copies of images in our application, and all our new features which we are building started using design library, but we never focused on our older features. So older features were still using the separate copy of images, and the new features were still using the started using the images from the design library. So this was something which we found out, and we started replacing all the images which the older features were using with the images in design library, and that helped us like remove a duplicate set of images, and we saved a lot by doing this exercise. So the next thing which we did was like converting images to WebP. So WebP is a image format which takes 25% lesser size than other image formats like PNG or JPG, right? And because of the same reason, it loads faster as well. Since the size is less, it is faster to load WebP images. So we converted all the images which we had in our application to WebP, and that helped us again save a lot of size. The next thing which we want to look at is resource table basically. So let's look into how our resource table looks like, right? So if you try to open a resource table in Android Studio, you will see something like this. So if you look at string, the resource table has an ID generated for each string, and it stores all the string values you can see here. And then if you read this statement, right, there are this many string resources across 5 configurations. So this was something which we figured out, that the configurations for us was 100. Which was like around 90, more than 90, 94 or something. And then we were like shocked to see it, because we were only catering to 5 at that point of time. We were catering only to 4 countries, and then we like also like later we were catering only to 3 countries. So we worked on it. So before we were catering to 94, our application had 94 resource configs, and since we were catering only to 3 countries, it did not make sense for us to have all of this shipped in our APK. So we worked on this, and when we removed all of the resource configs which were unused, our APK size reduced by 4 MB. And actually all these resource configs were actually coming from external libraries which actually wanted to support for multiple countries, right? So this is one thing which we did to reduce our resource table size. There was other initiatives which we took. One is like removing unused resources and strings. So the Android link was giving us a lot of false positives. So we wrote our own scripts to get rid of unused resources and strings. We also built some tools to prioritize how we can remove like libraries from our APK which were like very least used, or were not required, right? Were unused, or were not important to us, and that again saved us some size. And also the last thing which we did is remove the stale code branches. So we in Gojek have built, like whenever we build a feature or like do a redesign of an existing feature, we generally put them behind feature toggles, so that we can revert back to them in case of any issues. So but those, once the newly built flow is successful, we never go back and remove the old flow, right? So because of that, we end up having two flows in our code, and one is never used. So we, as part of this initiative, we also removed all our stale code branches, and which saved some size, right? And then like with all of this, we were able to save around 10 MB of size in driver app and around 11 MB in customer app. So which was great achievement for us. But the problem doesn't end here. Later we found out that a lot of drawables or images from our design library were still not getting removed from our APK. So let's assume that the design library which we built had 1,000 images, but only 100 are being used in one particular app, right? So it did not make sense for us to ship all the 1,000 images in our APK. And this was again something which we wanted to look into, and how to remove those 900 images which were unused. So we started looking into our DexGuard rules. So DexGuard is kind of a paid alternative to ProGuard, or now R8, right? So which helps with code minification and shrinking. So we started looking into our DexGuard rules, and to find out why this particular set of images which were unused were not getting removed, right? And we found some faulty rules. So if you look into these rules, right, we were referring to some of we were adding generic rules to some of the modules in our app, and these particular modules had reference to our design library. So because of these rules, the R file of those of the design library were not getting removed, and all the references inside that R file were still being added to our APK. So because of this, we still had all the images in our present in our APK which were still unused. So we, once we fixed this rules, we found out that we were able to save around 4.5 MB in driver app and around 15 MB in customer app because of this. But still, there was more to it, and because of this, we were able to save around 4.5 MB in driver app and around 15 MB in customer app, which was a huge achievement for us. And then we started looking further into few, like we found out that still there were some images which were not getting removed from the consumer app, and we started looking into other rules as well. So after fixing the faulty DexGuard rules, we saw that we were able to save around 4.5 MB in driver app, but there was still no reduction in customer app. We found that still the resources which we had in customer app were not getting removed, right? So we started looking deeper into why the customer app was not being benefiting from this particular change, and we found out that there were some rules which were quite generic, which were keeping all the references to all our R files, and these rules were being inherited from like multiple libraries. Some of them were one of them was third-party library, and two of them were from our internal Gojek, right? So those libraries had these generic rules which were getting inherited in our app, and because of those, we were not able to get rid of any resources in our application in the consumer app. So once we asked those particular teams to get rid of like make these rules more generic, we were able to reduce 21 MB in our customer app and around 4.5 MB in drive, like which was already happening for us. So this was a great achievement for us in customer app. So if you look, like after doing all this exercise, we actually saved around 30-ish MB in customer app and around 15 to 16 MB in driver app. Yep. So after all of this, right, what we found out is still we were shipping everything inside our APK to each user. So let's say a user was in Singapore and he had a device which was an LDPI device and a particular architecture, right? So still we were shipping all the different configurations of our images, and also like all the strings or resources which were not meant for Singapore to the user, right? So this was how it looked like. So we had all our resources of different screen densities. We had different native libraries and like a lot different features and all our resources, right? We were building them into a single APK, uploading it to Play Store, and it was getting delivered to each use all the users. So all the users were still getting all of this, which was not actually required. So we worked on this part, and we shifted to a new publishing format by Google, which is app bundles, and that helped us customize the delivery for each app, right? Each user. So now we were shipping an Android app bundle to Google Play Store, which had all of this thing. And what the Play Store would do is it would create thousands of APKs, and each of the APK would be delivered to a particular user, right, based on his device. So if a device is an HDPI device which has an x86 architecture and he is in Indonesia, so that particular user will get only those parts of the uh, APK and not everything else. So this further helped us in delivering smaller APKs to our users. Uh, yep, and the feature part here, which is like which can be done through dynamic delivery of features. So a lot of features at Gojek which we build are targeted for a specific country or region, right? So we also wanted to work on it and see if we can make a lot of our features like dynamically deliverable. So we are still like working on this, and we'll continuously keep working on this to make sure that the APK size remains small. Yep. So with all of this, right, all of these reactive approaches which we discussed till now, still we have one problem, right? So let's say, for example, we removed a lot of images from our code base. We converted a lot of images to WebP, and we removed a lot of unused libraries. But how do we keep that from happening again, right? A developer might go and start adding new PNGs or add new libraries to our application, and our application size will again grow. So to stop that from happening, we took some proactive approaches, and we'll be discussing that now. Uh, so we added some guardrails for all non-vector and WebP users. So we wanted our application to only have vector images and like WebP images. So apart from that, we do not want any other images to be added in our APK. So for that, we added a pre-commit hook. So as a developer, if he tries to add any non-vector or non-WebP image, he will be getting this error while making a commit that he has to change these images to the desired format, right? Or if he is somehow able to push them to the CI, we have an error on CI as well. So it will like the CI build will fail, and he will be seeing this error, which will ask him to change the images to the required format. And then we also don't want our developers to keep adding new images, as we have design library built for that, right? So we want our developers to use all our images from the design library. So if any new images are added, which are even if WebP, we throw a warning to the user so that it can help them go and look into the design library and find an alternative for the added images. Yep. And then the next thing which we did to as a proactive approach was like bring more visibility around size increase with every change which was going into our app, right? So we introduced a new check on our CI, which was like which used to check the APK size of the current build with the previous build, and send a Slack notification if that particular if the increase in size is above a particular threshold. So this particular notification was visible to everyone, all of our developers, and we actually could discuss about it whether this particular change is necessary or not, right? So this would again help us keep a track on how our size is going up and what are the changes being shipped, and improve those changes. So yeah. And one more thing which we faced as a problem was when we were working on this APK size thing, right? Let's say in a particular release, we put a lot of effort and try to reduce our APK size by 4 MB. But on Play Store, when the application was being shipped, we found that we can see only 2 MB of change being reflecting on Play Store. So we wanted to know why, where is the other 2 MB which we saved gone, right? So we also found out that those changes were coming from new features which were being added to our APK. So to bring more visibility in the changes which are going into every release, we had built a tool so that we can generate report between the diff of previous release and this release, and compare them to find out if there was any unwanted change, and so that we can uh, get rid of it in our next release, right? So we built a tool which was easy to integrate with CI. It can it can generate differences between any two APKs, or let's say any two commits. So if you have any two commits which you want to see the diff between, you can actually use this tool to get the difference. And let's also look into what that reports generate, some of the important parts of that report. So the report gives you this visibility where you can see that what part of your application, right, what different so we have code, assets, native libraries, and resources in our APK. So which particular part changed by how much size, right? So if you can see here, it gives us visibility around, okay, our code part, which is like the Java or Kotlin code, right, which we have, which goes into classes.txt file, was increased by around 260 KB. Our assets were decreased by this much KB, and then native library decreased by some MB. So this was something which should give us around what is actually increasing or decreasing in our new release, right? And then it would also give us details around the different packages which we have, and how which are the top 5 packages which are contributing more to this particular release. So if a new package is being added, it is like flagged as an added thing, and what was the size contribution of this particular package we are able to get. And along with this, we also had a raw file which would give us like more in-depth details about everything. So the raw file looks something like this, where we can see like all different things which goes into our APK, and what basically changed in those things, right? And so let's take an example of this library here. So it says that there was one library which was added, which caused an increase of this size. There was one library which was removed, and there were 5 libraries which were modified. And in total, there was a 1.8 MB of change decrease because of this library changes. Now, if I want to see which are these libraries which were being modified, I can go and look into them as well in this report. So each of the libraries which were changed or added are being mentioned here, and we could so similarly we can look into details for everything which goes like drawables, colors, or each and every package which we have, which gives us a lot of visibility around changes which are happening, right? So with this, like I would like to end my discussion, and like hand it over to Rahul, who will be discussing with around cold start time, and how we worked on it to improve the cold start time for us. Yep. Thank you.
Hi, I'm Rahul, presently working on mobile reliability for driver partner applications. And today I'm going to take you all through our journey of app startup optimizations. App startup at a very high level is the time taken by our application to become visible to the user. There are multiple types of startups. First, there is a cold start that represents the most amount of overhead for a launch, as the system is tasked with creation of our application process, followed by the creation of our first activity. Then there is a warm start, which has relatively lesser overhead as the application process is already alive and the activity may need to be recreated during launch. Finally, there is a hot start, which has the least amount of overhead as both the process and the activity are already alive and only the last screen needs to be resumed during a launch. Now, based on the guidelines from Google Play, exceeding the desired threshold for these qualifies as a slow launch. Out of all these startup types, first and foremost, we chose to optimize for cold starts for the following reasons. First, to avoid ANRs and app freeze issues on first launch. ANRs stand for application not responding, which is a prompt that the system displays when application has been unresponsive for a long time. Naturally, something that no one wants to see during an app launch. Second, provide a delightful first experience. Apart from ANRs being an issue, we also want to ensure that the app launch experience is swift and seamless to reinforce a positive sentiment while users use our app. Third, higher cost for late prioritization. A pileup of problems on app launch is not a very easy fix, something that can easily create a firebreak-like situation that could majorly impact our iteration speed and cause massive business impact as the releases stall. And fourth, to strive for engineering excellence. With the ability to measure yourself against your peer group, in strong engineering teams, there will always be a drive to excel at app vitals. Now we had a big goal ahead of us and even bigger challenges, which were difficult to size up initially, given the nature of this problem. Our first major challenge, reproducing a slow cold start in test environment. How do you fix a bug that is not reproducible? Even on low-end devices, these issues largely surfaced in the wild when the system was under stress due to I/O contention or limited RAM or CPU resources. And it used to mostly escape our radar while testing. Second major challenge, how do we measure cold start performance? With a wide array of application performance monitoring tools, what options should we consider to generate useful insights for our engineering teams? A lot of times, these problems can be very opaque, which means we get numbers against our metric, but still we are unable to dissect it further and can't make progress any faster. And the third major challenge, how do we profile release builds? Release and debug builds can be very different artifacts. To ensure that our efforts do not go to waste, we needed to make sure that we profile release builds in order to avoid blind spots. But that wasn't very easy given problems like false positives that could come up due to the profiling overhead and difficulty in understanding flame charts due to symbol obfuscation. So after evaluating a bunch of APMs, we decided to experiment with our production telemetry to catch these issues in the wild. Mostly because lack of progress was frustrating for our engineering team and speculative fixes costed a lot of effort given the long feedback loop from mobile release cycles. So coming up with our workflow, which was pretty simple. First, we used to capture cold start metadata for entire population using our analytics tool. Second, we isolated a segment of users that faces these problems more often in a week. Probably around 40% of cold starts are slow for these users. And finally, enable production telemetry for a small percentage of this cohort and analyze the flame charts for common patterns. This would minimize any overhead that comes from CPU profiling in production, and at the same time give us an accurate information about the screens that lag the most during a cold start. The tool that enabled us to carry out production telemetry is called Profilo. It is open sourced and maintained by Facebook, now Meta, which did a lot of heavy lifting under the hood to make this possible for us. Once we obtained these traces from the wild, our debugging time for solving these issues decreased rapidly. We extended Profilo's stack trace parser to reverse map the obfuscated symbols and use that to generate flame graphs. This helped us understand the code paths that are taking up a lot of CPU cycles and fix them. We were honestly surprised by our speed and precision of these fixes. Talking about some impact, within 2 releases, we were able to make a huge impact to our metric and create a lot of value for our users. As you can see, the impacted sessions came down by 13 percentage points, and the CSAT score for app responsiveness went up by 8 percentage points. It also felt great to receive this validation from our users as a result of these optimizations. So through this journey, what are some reflections we've had? Measure before optimization. There will always be many areas for optimization, but not knowing what will give you the most impact may misdirect your efforts. In our case, we had a bunch of starting points like flattening the view hierarchy, using view stubs, optimizing our custom views, etc. But around 30% of our results came from a very simple fix for offloading class decryption to a background thread. Second, be lazy. Identify your critical path and then aggressively prune out any work that's not related to it. Ensure that your application's on-create method is as light as possible and make it easy for other engineers to do the right thing as you scale by choosing to invest in the right abstractions. Third, do not block the UI thread. Most phones these days have more than 2 CPU cores. Use them effectively and don't block your UI thread unless absolutely needed. Beware of traps in your dependency injection where accidental file IO could be blocking your UI thread. Generally, it's a good idea to keep strict mode enabled on test builds. Fourth, inspect implementation details. Profile your application regularly to understand the implementation details of your code. This way, you'll always be aware of the biggest opportunities, and sometimes you might be surprised at the findings. A very recent example here was around a major redesign that we shipped for Homescreen, and where we noticed that incorporating profiling from day one gave us a very good result in our warm start, which decreased by 50% as a side effect. And finally, invest in guardrails. Avoiding human bottleneck must be done at all costs, because it's a very frustrating experience for developers to gatekeep quality manually. Investing in the right solutions that assist engineers to avoid errors and enable regression detection can go a long way. With this, I would like to talk about some guardrails that we've set up since we encountered and fixed this problem at Gojek. At Gojek, we've set up performance measurement suites on our CI to ensure that we are able to detect these issues early on. Our present approach relies on running n iterations of instrumented tests on reference devices that vary across low, mid, and high-end spectrum. This is run for each pull request that is made. The data that is generated out of these benchmarks is stored on the cloud, and we compare it against our sample baseline, which is nothing but the latest value of our last release for app startup. Since there could be a lot of variance for these tests, there is also a chance for a high amount of false positives in our alerts. So it gets important to maintain a high signal to noise ratio for credibility. Otherwise, once we lose trust, then the prioritization is probably going to suffer. So for this reason, we choose to pay very close attention to our alerts and how much noise are we generating or how flaky our tests are. Right now, we're in between strategies for the same, as it is slightly difficult to automate. But for now, we have two types of checks in place. One is a soft preventive check that runs periodically on the main development trunk and sends a Slack alert when it finds a regression. The other one is a hard preventive check that runs on every pull request and tries to protect us against the regressions early on in the development cycle. On the left here is a sample config file that defines what our baseline is and what is the allowed threshold for variance. And on the right is a sample depicting what kind of a Slack alert comes up in case we've noticed a regression. With that, we've come to the end of our talk. Thank you.